We are now going to implement another Fibonacci algorithm, except this time we are going to use a very powerful technique called memoization, and we are going to call our algorithm FibMemo this time. FibMemo will take in two parameters instead of just the one parameter that our first Fibonacci algorithm took in. The two parameters will be an index, which is the index of the number in the Fibonacci sequence that we want to retrieve. For example, if we pass 5 in as the index, we want to retrieve the fifth number in the Fibonacci sequence. If we pass in 7 as the index, we want to retrieve the seventh number in the Fibonacci sequence, etc. And our algorithm will also take in a cache as a parameter, which will be an array. If you remember our first Fibonacci algorithm, it took a very long time to calculate even small values of the Fibonacci sequence because it had a very bad runtime, which was exponential, or O of 2 to the n. That was because every time our Fibonacci function was called, it would recursively calculate every number in the Fibonacci sequence up to the index that we had entered. So if we entered the index 10, it would have to calculate the first Fibonacci number, then the first and second Fibonacci number, then the first, second, and third Fibonacci numbers, then the first, second, third, and fourth Fibonacci numbers, and so on. As you can tell, we were recalculating the same numbers over and over again, and this was a complete waste of time and very inefficient. But when we use the memoization method to produce a Fibonacci sequence, we don't have to waste time doing all of these calculations over and over again. The premises behind using memoization for our Fibonacci algorithm is that we will have a cache, or memory, of all the numbers that we already calculated. When trying to calculate the next Fibonacci number, we will first check to see if it already exists in the cache. If it does, we will simply use the number found in the cache, therefore saving us many calculations. If the number does not exist in the cache, then we will calculate it and put it into the cache in case it needs to be used again in the future. This is an incredibly more efficient way of calculating a Fibonacci sequence and will save us a ton of calculation time. Since every number will only be calculated once, this new and improved Fibonacci algorithm will have a O of n runtime, which is much better than the O of 2 to the n runtime our previous Fibonacci algorithm had. Let's code out our new implementation in the next video.